Hi guys, welcome back to our channel. Today we're sharing a recording with you of a Q&A we did at TrinSplash. In it, we're talking about creating your own math competitions, math camps, symposiums, math teams, writing problems, taking competitions, all these incredible things that we have a lot of experience doing, and we wanted to share that experience with you guys. As always, if you have any questions, put them in the comments below and we'll respond. And if you like this video, please subscribe. All right, let's get into it. And then the next thing we're going to do once you guys are done copying that down if you want to, is we're going to do a Q&A. So we have some prepared questions if you guys don't have any. But basically, we have a lot of experience like bringing math to people around the world. We've done competitions, we've done camps, we've done symposiums. I also have a program called Girls X Math that's all about getting younger girls into math, and so we all know stuff about like curriculum writing and problem writing and all these really cool things. So we were wondering maybe if you had questions about some of those, because we have a lot of experience and would love to share it with you. We'd love to answer them. All right, I'm reading question. Do you have any suggestions about outreach to students who would not normally attend math events? That's a really great question. Michael, do you want to field that one because you're so great with outreach? Or
Yeah, sure. So when we did outreach, especially for our first competition back in the spring, our goal was, of course, really just to sustain that sense of community that we all love so much from previous math or opportunities that we had done. And so what we did was we really tried to contact all the math coaches, in various parts of the world and parts of, like really across the world. Um, and in doing so, like we not only were trying to outreach to students who were interested in math, but hopefully like through those coaches, we encourage them, this is an open competition. It's completely free. So there really is no harm to, inviting students who perhaps have not done a math competition before to come and try it out. So that was, we really tried to, and for some schools where we couldn't find like the math team coach, we just like outreach to like the principal or the an administrative member, and I'm sure they also let students know who might not have particularly been interested in math before.
so if you want like a more step-by-step thing, what is a really good idea to start is you just talk to the math teachers at your school. You're like, who are the math teachers you know? Can I have their emails? Can I talk to them? And then you just start emailing people. Hi, this is my name. This is my school. I'm making this thing. It's free, and I'd really like to share it with you. And then through that, you can meet more and more people. And so it's really about not being afraid to talk to people, not being afraid for them to just like not respond to your email. But normally a good place to start is just talking to the math teachers at your school. Does anyone else have anything to say on that, or should I go to the next question? All right, next question. My school does not have a math club. How would I go about starting one and learning about different competitions? So I feel like that's like very much an Akash voice.
Kosh, you and Foyas can take this one from what you guys did in sophomore year.
I mean, I think it depends school by school, but for the most part, like if you're like excited to like start a competition, a club, for the most part, I would just talk to some like administrator or no, I don't know who it is in your school. For us, there's like designated people, just find some students who would love to join the club, see if there would be interest, and then pitch it to someone and ask if you can start that club. And from there, you have to, for us, this whole thing is we really started out being like, we're a very student-led team. So we lead, the four of us lead the meetings, the weekly meetings. We devise problem sets for kids to solve and just really promote that collaborative problem solving. And I think that'll give you a good, strong foundation. And then Akash, if you do want to talk about the competitions a little bit.
Yeah, sure. Just sort of reiterate what Boyce is saying, like on the sort of like logistical level, there is sort of like, like contact whoever is like in charge of these things and being like, I want to start a club and all that. As far as like actually being able to like grow it and all that, really like I think the most important thing is just like, I guess, commitment and energy. Basically, I think, now obviously we do a lot of things in terms of these events and competitions and things like this. But I think it really just starts out by having like a group of people who just really want to do math with other people who also really want to do math. That's the core of it, honestly. So for us, that we have this like time in the middle of the day, in which everyone is free. It's called ad hoc, and then basically it's when like all clubs can meet and all that kind of stuff. So we just made it very important to us that we have at least one meeting per week, and just make it very consistent. And I think just when you put sort of energy and time and effort into something, other people pick off of that. So we were fortunate enough to have a community of people who were interested in that, but obviously there is some effort that goes into galvanizing and energizing that. So just really being passionate about that process and that effort is something to keep in mind. Just just hosting these meetings, obviously like might start out a little slow, like we've had our fair share of meetings where like 2 people showed up, but like now like we do have like 20, 30 people who were like consistently showing up, which is really nice. So as long as you can like put in that consistent energy and time into it, you'll things will turn out well.
We're starting to get more questions, so
I mean, I'll just like add on real quick, just to Kosh, like learning about competitions. Like for us, it was just internet search, like just try and figure out what's available, talking to other people in the area. And just like one thing to add on to Kosh, like don't be like nervous, like if there's not that many people that like some people said, like what if you didn't, what if like you don't have like an advisor or things like that, or no one at your school wants to do it. It doesn't have to be at your school. If you have just like a small group of friends who would want to do it, like we started out very small, just like a few kids, like single digit number of students who are interested. And really, like Akash said, bring the energy, bring the commitment. We were really working hard to think about how many ways to expand it. And like just don't be afraid. Like if you have like a small number of people, it's really the hard work, dedication, like commitment that'll really determine like if it can be successful.
And as for what you do in those meetings, you don't have to make like the presentations like we've been making for these lectures. You can what we do a lot is we'll look at competitions that we're going to do or have done, and we'll just look at their problems. They should be posted on the website. TrinMac, we have our problems posted on the website. And then you just all try to solve it and help each other solve it and try to help the people that don't understand it. The next question is, at my school, none of the math teachers were willing to do it. Is there a way to start a club out of school that can still compete in the same competitions? Yes, like for us, the only reason we need a teacher to have a club in school, just like that's like the rule. But if you want to just do it out of school and have your friends, you can totally still attend the competitions.
Yeah, I mean, these like places are not very sort of like like rigorous on like, oh, like you need to be from like this district, from like this school, or whatever. Most of these places, like if you they're probably just fine if you have like a group of like 5, 6 people, and then they're just like, yeah, we'll take you, fine.
Yeah.
And then sometimes like that means emailing them. Like I remember there have been some times when like we didn't have enough Trinity people, so we had to like get people from other schools. And we just email them and be like, hey, is this fine? And then mostly like the people who run these things are just other people who like math, so they want to help you out. So it probably is fine. You can find your group of people who want to do this in school, out of school, whatever works for you, and I'm sure people will be accommodating for that.
Yeah, you're always welcome to do TrinMac, even if it's not through your school.
It could be like you could do just like a random group of people, like from like anyone you might meet. Just like it doesn't even have to be in like your same region. Like if you have just like people from all over the world. You have friends from like different parts of the world. Like for us, like please just if you want to send a team, we're more than happy to accommodate.
All right, what makes a good competition problem? How would you write one?
Yeah, I guess me and Akash can take this one. I mean, I guess it's really about first thinking about like, I guess I could talk a little bit more about like the general landscape of a competition. Like you don't want to have like a competition of 30 problems that are all algebra or all number theory or all geometry. So you definitely want to think of like, okay, like first I need this breakdown of like, okay, I want 5 geometry problems, 5 number theory problems, 5 algebra problems, and try and get like a nice even distribution of skills represented. And then from there, there's a lot of different approaches. for me, of course, like you don't just like sit down, and you can definitely sit down and think of a good problem to write. Um, the best way to do it was think of like, what sort of skills do you want to represent in this problem? Do you want someone to use generating functions? Do you want them to use permutations and combinations that we talked about? What sort of skills do we want to represent? And so think of like a solution and how you might incorporate that uniquely. And then from there, it's one, working out the numbers, and two, finding a scenario that fits it, right? So really, I would say like you start from the solution, thinking about like how you want the solution to look, making sure the numbers work, and then going and finding a scenario that fits it, in which it's not like super obvious that this is the approach you take. And I will say, it's not like how you can like see like a math problem sometimes in class and just like quickly just go and solve it. And just like, okay, like I know how to go from A to B to C to get to the answer. Here, like, to be honest, like I'll be like walking from class to class or things, and you know, I'll just like think about these problems in the back of my head, and sometimes you'll just get an idea that clicks in the middle of the day, and like you can quickly write that down. And that's like it might not come to you at first, and that's something that's important to understand. Akashi, if you want, you can talk more about just like the actual mechanics.
Yeah, sure. So yeah, I mean, there is sort of like that logistical aspect, and like you want to have that like even distribution, and you know, there's obviously a lot of things that goes into competition like outside of problem writing, though that's probably like the hardest, or at least the most time consuming part at times, because you just have to make new content. But yeah, I mean, there's sort of different approaches. Like, I know when we were writing, there were some people who like kind of just like inspired by other questions will just like make some new one and then just see if they can solve it, like essentially just generate a random question, then just be like, okay, is this thing that I made like actually solvable? And that's led to like some fun problems. For like me personally, and I think boys as well, like I tend to, I think, to like work backwards. So kind of what Foyz is saying. So one, normally you start on like some sort of like theme you want to get across, like some like main idea that you want to be like the core of your problem, and then you're like, okay, like how could I, you know, maybe layer another idea on top of that. So if like it's in geometry, maybe you're like, oh, like I want, you know, the first part to be, maybe you get like a side length with some log cosines, and then after that, you know, I think it'd be cool if you get this angle with log sines, and you kind of just like build it up from there. And then you can also kind of like judge how difficult a problem is based on sort of how many things you're layering to create that problem. But you know, a lot of the time it's less, I guess, planned or mechanical than you'd think. I mean, a lot of it just comes, especially when you have problem writing on your mind. Like when we were planning the competitions and all that, it was something I had in the back of my head. And then, you know, I was just like learning a new math idea in some math class, and you know, it would kind of just like come to me at the time, like, oh, you know, like what if we you know, thought about this concept in sort of like a different angle, and then that could lead to a problem. So a lot of times, kind of just like a frame of thinking, and these things will sort of just come to you. But I would say, like, if you're just kind of just like sitting at a desk and like being like, I want to come up with a problem now, that's probably a little tougher. But like the backwards way of thinking is probably your best bet in terms of like layering different ideas, different but like related ideas on top of one another.
Yeah, and I mean, just like quickly adding on, like at first it's gonna seem like hard to write good problems. Like I talked about, like our first competition, like yeah, we wrote a lot of bad problems, and again, I said we trashed more than we kept, and that's like we were writing for quite a few months. And I think the best thing to do, like if you're like, of course, like younger, like of course, give you a shot, take like just try out writing problems, just try it. Of course, it might seem hard, but to really like, if you want to become better and better, like a thing that I would just suggest is getting exposure to math problems, different math problems, like the sort of exposure that if you can get like just look up combinatorics problems or graph theory problems or whatever, if you're able to get that sort of exposure, like we post like a lot of these things online, and just like with you know, we have our YouTube channel and like Trin Math Camp that we held, and we have a lot of good problems there that are not taught really in the classroom. Those were problems that I never learned in the classroom or saw in the classroom. So getting that sort of exposure to problems by like reading interesting math books that are not like what you would traditionally learn in school, that's really important, because once you start getting into that mindset of like, okay, there are these really cool problems out there, just that exposure will help you.
It's not bad to take inspiration. See a cool problem, see that's a really cool way of solving something. I never heard of that before. I now want to apply that to my problems. And you basically just like add numbers nearer to the end. The first part is, what do you want to kind of get them to do?
Yeah, I would say like you don't have to like rush anything. Also, like sometimes like people are saying, oh, they need to rush into learning math. Like that, if the way you gain the most out of it is like sitting with a problem and truly understanding, like, okay, like this is what the problem writer was trying to get at. Like this is the purpose, and like trying to understand like what's going on, and you'll really start to understand like the mechanics of like how a problem might be inspired. And so, yeah.
Are there any international competitions that aren't exclusive to one country? And can you talk more about finding competitions?
Purple Comet is a good example, probably, because one, it's online, like even when things aren't weird. So that's pretty accessible, and it's international. They have a lot of people who do that one. So Purple Comet's definitely a lot of fun. Some of the ones that typically are, in some sense, like a lot of things are online now, so it does open up a lot of pathways. So, for example, like HMMT, it's this competition organized by Harvard and MIT students. That's online now for obvious reasons. So, and you know, they had no cap on how many people they could take now because it's online. So there are a lot of places like that. The AMC is a pretty well-known one.
I think it's America, though, with American Mathematical Competition.
Oh, they don't.
I think.
Like my cousin like talks about taking it or whatever.
I just put some examples in the chat. Like there's Nemo, which is the internet Olympiad link, and there's MathCon. But there should be a lot of, as Akash said, especially during the pandemic, it's a lot easier for competitions now to do it internationally. Like, you know, for example, us. But for a lot of competitions that, you know, were traditionally just like, you know, within a local region, there's no need for that. And I'm sure if you look up, like, you know, a lot of the college organized ones and other competitions are all going to be international. So there should be plenty of opportunity for that.
And as for finding competitions, we literally just Googled, like, I think Mila referenced it, but there's a list on art of problem solving of some competitions. We have like, we Google it, we have a spreadsheet of like, here are the competitions, like, here are the dates, here are when, sometimes you have to apply to get into a competition. Like, so like, here's when you need to apply. And then we just see like, oh, we want to do a competition coming up, which ones are coming up. There's not, you just Google.
Also, if you are international, there are very likely going to be competitions that are, you know, national for your country.
Yeah.
And of course, you know, we don't know about that too well, but there should be plenty. So if you search up, like, if you're in the UK, for example, you search up, you know, Britain high school math competition, I'm sure you'll find some good results.
Yeah. How long will it take to get fully prepared for competitions?
I think it depends. So just getting, if it's a team competition, really, like it's about just understanding the team dynamic as often as you can meet. I don't know if there's a specific timeline in terms of getting ready for a competition. You know, just meet often, do a lot of problems. Like if you're all like we talked about, like the dedication and commitment, if you all really want to just like meet every day and just like do the problems, like that's awesome. But like if you guys are also like very busy, we also like we all understand that we're busy high schoolers. Like if you just try and find some time to meet, there's no timeline. Like I would say the best thing to do, like if you want to do well in competitions, is get a lot of exposure to like the competitions. Like do as many as you can. If you can't find like too many in your area, just email us. We have like a lot of resources. The trinmacnyc@gmail.com email. You can email, and we can definitely help you get some resources.
Yeah, as for us, we're always practicing for competitions, but like if we have a competition coming up, we meet weekly. We'll maybe have like 3 weeks where we're like looking at problems from previous competitions, and then like 2 weeks after where we look at like the problems we just did and reflect on them and talk about those problems. It's like studying for a test. Like you just study a certain amount. You're not necessarily going to know every single thing ever, but just like the extent that you want to study.
Teams, I think as Boya said, I think it's useful to sort of like lean into your individual strengths. So like, for example, like I know that, typically like I like to take the number 3 questions. It's like, that's something I'm a little bit more passionate about. Or like, like other people will take like geometry because like, honestly, I suck at geometry. And they're way better than me. So kind of like leaning into like what your individual preferences might be is something useful for team competitions. Just like kind of understanding like what your strengths are and then like being able to use those.
Are there any resources to practice for this competition? I'm assuming you're referring to TrinMac. We post all our old competitions and their solutions and answers on our website, trinmac.nyc.com, so you can look at those. And then we also have a YouTube channel where we talk about some cool concepts, and we record sessions from this and TrinMath Camp, so you can totally learn about cool new things that way. How do we do TrinMath? I think you're saying TrinMac outside of our school. When you just not apply, but you sign up for TrinMac, you can just say like we're from a mixed group of schools, and we won't question it.
In the future, like we may just ask like if you don't have a team, if you just want to sign up as like an individual who's also interested in doing teams, like you can do that, and then we could just place you with other individuals who are also very similar in the sense that they don't know anyone that they can join a team with, but they'd love to do it with some other people, and so we could just like pair you all together.
Yeah. Do contest math problems help in learning advanced concepts like calculus?
I would say the contest math problems are very different than like learning calculus. It's very like, it's just not comparable, because when you're in like a course that's focused like like I said, analysis, calculus, algebra, there's a very set structure, and you're trying to learn these sorts of like skills. Sometimes they're somewhat algorithmic. Sometimes they're more like just like visual. I would say like the contest math problems are not calculus based. I'm pretty sure for most of them you don't need to know any calculus. So it's really just like the contest math problems give you the problem solving ability to like approach a problem, like be able to see a problem and say, oh, okay, like how might I attack this problem? Like what are the sort of clues that this problem is giving me that I should go down? And just having that like consistent like math practice and problem solving practice, like that's what's really gonna help you in a course like calculus or like any other math course.
Yeah, the problem solving is very important. Another thing to note is that a lot of these competitions, at least at an early age, are not going to be proof based.
Mm-hmm.
There are competitions that are proof based, but it's more rare. But like in comparison to a class like calculus, for like maybe like geometry or pre-calc, like sometimes teachers are going to want you to actually do those proofs since they're more educational in a sense. So they actually like make you understand the concepts that actually like lead to theorems or lead to rules in math. So in that sense, it's also really different. But of course, like regardless, with competition math, the problem solving aspect is a really, really important benefit.
Yeah, I mean, just like down to that, obviously like the content is like different. So I mean, for example, like learning about like combinatorics or number theory like did not help in like terms of like solving integrals or whatever. But it is about sort of that problem solving mindset. And I think like most importantly, it's about sort of being comfortable with uncertainty and like not knowing something. Like there's a lot of times like you're faced with a problem like on a test or otherwise that like you go into it and then you literally have like no idea what they're saying or like what you're supposed to do. But I think for like competition problems and sort of things like that, probably one of the most important lessons is just like being able to be faced with something that is mind-boggling. You have no idea what to do at first, but just like being comfortable with that and then just being able to approach it calmly and just try different angles and just keep attacking it from like different perspectives. So it's useful in that sense. I mean, that goes for math and like anything else, honestly. Like it helps in any other subject. I mean, it's helpful for me in like computer science or like physics or chem, in other areas as well. So it's just an all around like useful skill and approach.
It's almost okay. Yeah, I know a lot of you are mentioning in the chat that like yeah, we'll have a lunch break. You can also, if you want to continue asking questions, like I'll stay on. I don't know. We might, some of us might stay on, and you can just continue asking questions during the lunchtime if you want. But feel free just to like turn your camera if you don't want, turn your camera off and eat if you want. Yeah, officially it's 1 to 1:30, but like yeah, if you still have questions, like yeah, I'll be here at least. I'll be here.
Yeah, we'll have one more question for like the official Q&A, and then for lunch, just you can turn your camera off for 30 minutes or you can stay. But the last question that I see here is, can you tell us about your math journey and how you got to where you are now as far as knowledge and passion?
Yeah, I mean, sure. I liked math from a young age, I guess. It was something that was interesting to me, and like my middle school was quite serious with its math team. So that's really where I got involved. I think I was at least lucky enough to have like this sort of like enthusiastic group of math students around me, and I just like solving problems with them. So that was really my first real exposure to like mathematics and really taking it seriously. I would say in high school, I like the competitions, but I also like I started doing research, and I started with mathematics, and that's where I really like fell in love with like the subject. It's very applicable, and it's like the research part of it is just understanding like that the fact that there's like an unknown that no one knows, but you're trying to solve it with different angles. There's no set answer, so it's not like, oh, like you just look this thing up online and figure it out. You're trying to solve the unknown. And for me, just seeing that mathematical manipulation go into it, that innovative thinking, thinking about math not just during class but like any other time, like it's a nice feeling, like when you're just going about your day not doing math and you get this really interesting math idea uh, in the middle of the day, and that might be really useful in a project. So that for me is really why I love math.
I think I really love math because I'm kind of a perfectionist, and I like the idea that in a lot of the problems, I guess like the more basic problems, like there is an answer that you can find if you like are able to find the trick or work hard enough. And to me, that's very satisfying. And then as for my journey, I'm just like, I've always been really passionate with meeting people like through math. And so I like join all the math clubs possible and everything. And it's like really fun to hang out with like-minded people. And that's also, I have this program called Girls X Math, which is like mentorship for younger girls in math. And by the way, if any of you guys are interested in that, I have a whole curriculum for that I'll send out if you want to bring a Girls X Math to your school, because it's really, really fun. And then Akash, if you want to.
Yeah, sure. I guess I probably got into it because of my dad. He was always like pretty into math and like always just kind of implicitly put that in things in my life. Like I don't know, we'd like play soccer or something, and he'd always just like make me count up the scores and stuff like that. So it was always just like something he kind of stressed. So I got into it. I think once I started like pursuing that more formally, it transformed into something like more of a passion. I think like earlier when you're kind of into math and like lower school, that just means like you can like add numbers kind of fast or something like that. But I think when I started doing it like in programs and all that, and then that sort of like transformed to like actually sort of like appreciating like how in like intrinsically beautiful like the results of math like can be, like seeing all its sort of interconnections and just like how elegantly everything works out is something that I really enjoyed. And obviously like pursued that further along the way, kind of just builds up and up and up. But that's sort of like the main reason is I just find it sort of, I don't know, almost miraculous at times, like how all these ideas can sort of like intertwine together.
Thank you so much for watching. If you want to see more videos like this, either subscribe or watch other videos we've posted. Bye!